All right, good afternoon, chemists. We'll get started now. For those of you up there, there's plenty of room upstairs. There's a second floor. Yes, there's a second floor. All right, so hello, chemists. I'll be your lecture instructor. I'm Dr. Lisa Wynn. Welcome to Chemistry 1210. Right? So we have some introduction slides to get through, and then we'll start chapter 1. So lots of stuff to talk about. So these slides, I have my introduction syllabus slide, so I'll actually just show you our Carmen page first, so you know where to get all of this information because the slides are posted for you. So I will show you our Carmen page. All right, so here we go. Our Carmen page, so I'm using the Canvas app, but you can access Carmen via your laptop in a web browser. I actually like the web browser version better because you can see more of everything. So I'll point your attention to the modules section of our course. That's where you're gonna find all of the information, and that's how I organize all of our materials. So you see these different folders here. I'm responsible for the lecture and recitation portions of this class. So you see here, there's a start of term tasks at the top here, and I have some folders with lecture material. So here you see there's the first week of lecture, so everyone has access to this right off the bat. But I'm gonna ask that everybody completes the syllabus gatekeeper quiz. This is just me forcing you to read through all the resources. Once you get 100% on this quiz, you'll be able to unlock the rest of the lecture material, which I will put chapter 2 and 3 materials on there. So you will need to take that syllabus gatekeeper quiz. For those of you looking for a seat, there is plenty of room on the second floor. Second floor of this room. All right. All right, so the syllabus gatekeeper quiz, you'll have to read through all of my resources. So like course logistics page, I just summarize the syllabus, and I have a page of frequently asked questions. Highly recommend you read through this. Control find, all right, your questions on there before sending us an email, because 99% chance that the question you have in your head right now is answered on this page. All right, with the appropriate links to get the information you want. All right, so keep that in mind. So I'll turn your attention to this chapter 1 page. So you'll notice that I organize this class by chapters. So we have 12 chapters to cover in this class, and so there will be 12 different chapter pages with all of the information for each of those chapters. So you see here on chapter 1, page, you see the syllabus slides for you to download and send to your device or print out however you wish. So do grab those because I'm going to move to those slides here in a little bit. But what you'll see here also are the lecture slides for chapter 1 that we'll dive into as soon as we're done with the syllabus slides, links to online homework, and a ton of supplemental information to help assess your learning as we move through the chapters. So I want to show you an example of my extra practice problems that I post for every single chapter and my very detailed worked out colorful key for each of them. So, you know, to really make doing practice problems on your own easier, I provide tons of practice problems and detailed explanations and keys for all of them. Right, so you're never alone in doing practice problems. I want you to do as many practice problems as possible so you can prepare for exams. And so I have these resources to everyone because personally, that's how I was able to succeed in undergrad. Is I did lots of practice problems. I literally purchased the solutions manual to every single one of my textbooks so I could do practice problems. So I want to make that equitable for all students, so I have very detailed solutions manuals, basically, to my practice problems, because I want all students to have success the way I did. So for those of you in the back, there is tons of room in the upstairs. Yeah, if you just take that exit, there's a staircase. Yes. All right, so those are resources for you. Every chapter will have them. You'll also see here supplemental lecture videos made by another instructor. So if you don't like the way I explain something, there's resources for you here to see it explained by a different instructor. And also here at the bottom, you see there's a spot for lecture recordings. So I am recording the lecture right now. Right, I am recording it right now. There is no live Zoom option to do with lecture. You either have to come in person or rely on the video that gets uploaded later. And so, sometime by the end of the day on this page, it'll update with the video once I edit it and post it. So that's where you'll find all that information. Right, so we're going to dive into the syllabus slides here, so do download these and download the chapter 1 slides because we'll start that here, here too. All right, so let's go into course logistics. All right, so a little bit about me. So I had this up earlier, fun pictures that emulate me. This is like my dream board, all right? So yeah, call me Dr. Wynn. So my name's Dr. Lisa Wynn. I was actually named after Lisa Simpson, all right? If it shows you my age a little bit. Call me Dr. Wynn. It's pronounced win like the Bucks will win the championship game, so simply like that. There's a lot of silent letters in it, but that's like the Americanized version of it. Or call me Dr. N. A lot of students do that, especially in email form because of all the crazy letters. So these pictures emulate me. So I live on a hobby farm with my 2 cats and 8 chickens and 2 ducks and my husband on our hobby farm. So here are my 2 cats, Atlas and Bean, enjoying farm life. Here are some of my chickens and their names, if you care. Popeye, Yeti, the evil one, Blackie number 2, and Beethoven. I actually have a sick chicken right now. She's in a crate on my dining room table, and as soon as office hours are over, I'm gonna go run home and take care of her. So those are my chickens. This time last year, I actually purchased some like baby ducks and chicks. And so that year was kind of fun. All the students that I had in 1210 and 1220, we all watched them grow older as they grew older as chemists, and so that was kind of fun. But they're older now, they lay, and all of that. So that's me. I like to bring examples of the farm to class and real life examples to class, so be on the lookout for that. What else about these slides? Oh, my 3 favorite places on earth are my farm, because there's always lots to do and I'm never bored there. My second favorite place on earth is Disney World. I was just there a couple weeks ago. It was my first vacation in like 4 years. So we were there for a week. It was very fun. Drank and ate around Epcot all around the world. That's what we did every night. And then my third favorite place on earth is Costco. So that's me in a nutshell. All right, so that's me. You'll learn more about me this term. All right, so what to expect with this class. So you are in lecture right now. I am your lecturer. So I'm responsible for this space Tuesday and Thursday at 12:45 p.m. You have a fleet of other instructors who take care of recitation and lab. So I'll point out, because a lot of you are freshmen, you've never been in college courses to this capacity before. When you signed up for this class, you signed up for my lecture, but you also signed up for a lab section, right? You remember that, right? Keep in mind that lab section has a different number. You need that number for lab right when you do the registration for lab stuff. It's a different number than our lecture section number. So if you can't find the number, it's because you're looking at the wrong lecture versus lab. All right, so when you registered for lab, there was actually 2 classes listed. One is a 3-hour course in Celeste. That is your lab. Then there was a shorter class that was 55 minutes long. It's somewhere on campus, but that shorter class is called lab in your schedule, but it's actually your recitation. Recitation is just a smaller group of students where you do practice problems with a teaching assistant every week, a different day of the week from lab. So do recognize that lab that you signed up for has 2 different classes. You go to both week to week, all right? So yeah, one recitation, that's the short one, and then your lab session with a teaching assistant. And in addition to that, I assign an online homework assignment, one per chapter. We'll talk about that a little bit later. So that's what to anticipate your weekly schedule for this class. 2 lectures, Tuesday and Thursday. You have typically a lab a week and a recitation a week. Right? We also have 3 midterm exams, and these occur in the evenings, right? And we'll talk about that in a little bit, and a cumulative final. We'll worry about that at the end of the year. All right, so we have a lot to cover. This goes fast. I'll make lots of announcements to make sure everyone's on track. All right, so I know we have a lot of anxiety for this chemistry course. You may have certain biases coming into a course like this, of this size, this rigor, but my goal here is to make things not as easy as possible for you, but as transparent as possible for you. So here's the grading scheme that we follow to assign your letter grades. This is in the syllabus. I'm just summarizing it here in my own words. So you see here, we have different percentages for each grading component in this course. So our midterm exams, those 3 of them, they're weighted equally, 14% of your letter grade. Our final is worth 20% of your grade, and lab is also 20% of your grade. Note here the asterisks. In order to be eligible to pass this course at all, you must earn a 50% in lab to pass at all. So this 50%, students get worried about it, but don't worry about it. Rarely do we have to fail students because of lab. It's the students who don't meet that 50% criteria. Those are the students who just don't show up to lab and don't hand stuff in. So if you hand stuff in, you make an attempt to go to all the labs when they're scheduled, you will surpass that 50%. So don't worry about it. It's those students who just don't show up that does affect. So keep that in mind. So those are our lab percentages and our assessments here. What I'm really responsible for is the grading criteria for online homework and recitation. And we'll talk about these in a little bit. Recitation is purely attendance-based, all right? And we'll talk about online homework here in a little bit. So these points do populate your Carmen grade book, and you'll see those grades populate. Once we get further into the year, towards the end of the year, that percentage that you see will be more accurate in reflecting your final letter grade. So percentages you see right now where we don't have that many points assigned yet, don't sweat it. Let's wait until our first and second midterm before we really start thinking about our grades. So I have some commonly asked questions down here about grading. That's where a lot of our anxiety comes from. So the first thing here is no assignments in this course are curved. Nothing is curved. The raw points that you earn go towards your letter grade, right? And the percentage that you see in Carmen, nothing is curved. Instead, and so students, they often ask oh, what's the curve in this class? There is no curve. Instead, we use a grading scale that is already curved, right? And so this is in your syllabus. In order to earn an A in this class, you have to earn 92% of the points in this class, right? So see how it's already pre-curved? In order to get an A minus, you need to get 88%, all right? So this is the curve, all right? But the difference here is that we're publishing the curve before the end of the year. So you know exactly how many points you need to get the letter grade you want. And so this is, in an effort, the department being more transparent, alleviating that grade anxiety that students often have at the end of the year. You know exactly what you need to get the letter grade you want, all right? So there is no curve. The raw points you earn go towards this grading scheme and this letter grading scale. So everything is in your control. You can calculate your grade at every single point in this semester, all right? There's no, is the curve gonna be, help be in my favor, at the end of the year? No, you already know what it is, all right? So that is our in efforts to be more transparent. So Grading scale, and then the last question here, is there any extra credit in this course? No, there's not. Because of the absolute grading scale that we're using, if I gave extra credit, it would screw up everything in our grading scale. So there is no extra credit. But do keep in mind that online homework and your recitation grades, those, or attendance, that's points in your hands that you have direct control over. All right, so keep that in mind. All right, so that's grading. Lecture schedule. We have 12 chapters to cover. In the syllabus, I have the lecture schedule, but do understand this is just my estimate. If we will absolutely deviate from this a little bit. So here in the schedule, it says that we'll finish chapter 1 on Tuesday. You know, if we don't, then that's okay. And I will adjust due dates as necessary. So we will go through the chapters in sequential order. So if we have to deviate from the schedule, we're not going to jump ahead to chapter 2 until we're done with chapter 1. All right, so just be aware of that. If we have to deviate from the schedule. But what I want you to focus on here are the exam dates, all right? So our midterms, because of the large scale of this class, I actually have another 1210 class that was right before your class. So I have 2 different 1210 sections, 300 students in each of them. There's a total of 11 different 1210 sections. There's about 3,000 of you. All right, so we have to have these outside of class exams to accommodate all of you. All right, so these exam dates are in your syllabus already. Write them down now. Oh, there is room. You don't have to sit on the floor. There is room on the 2nd floor. If you go through that exit, there is a staircase up there. Yep. This happens every first year, right? You don't have to take a picture of this. This is in your syllabus. It's in your syllabus. So these exam dates, write them down now. Okay, put them in your calendar, figure out if there's a conflict. We do have policies in place for if you have conflicts, like if you have a class conflict, right? So these are our exam dates, and our final exam is scheduled by the university during finals week, right? So your exams are on Tuesday evenings, and I will be there to cheer you on. Right? I can't help you, but I will be there in spirit to cheer you on. So the majority of you will be taking the midterm exams in this outside of classroom time, also in Hitchcock, which is a different building and different room on campus. We'll talk more about that when we get closer to it. But some of you, if you have a conflict, we'll arrange something with you outside of these times. But also, if you are an SLDS student with exam accommodations, we do have policies in place for that as well. We have pages that explain SLDS exams. So if you're an SLDS student, in short, it's your responsibility to schedule your own exam and trust us that we will have an exam for you at SLDS. All right, we have pages on our Carmen page that explain that, but if you have questions, come see me and I will try to answer those. But the majority of you will take the exam in Hitchcock. All right, so exams, schedule, all right. So I mentioned before that I am responsible for recitation. So many of you have probably never been in a class this size, all right? So I can only lecture for so long in front of so many of you. So recitation is meant to be a small group activity where you're just actually with your lab section, so 25 students, and you work personally with a teaching assistant to go through practice problems that I arrange for you. So it's a small group learning space, all right? So it's meant to be different, a different feeling than lecture. It's not a 55-minute lecture. It shouldn't be. You should be doing active learning and practice problems. So where your grade comes from in recitation is purely attendance-based. You need to be physically present in that room. Maybe not mentally present, but physically present in that room. So if you look at your schedule, and you find the 55-minute like short lab recitation time slot, let's say your recitation is on Wednesday, all right? So how we read this schedule is all you need to do is read that Wednesday column, all right? So that means if you have Wednesday recitation, you meet on Wednesday, but it's not graded. Your first graded recitation will be next week, so that's a small detail. So how you get points for recitation is attending these graded recitation days. And we just take attendance, and if you are present for the duration of that recitation, you get 10 points. So I've automated it for my teaching assistants where for these graded recitation days, I share a password with them, and you just take a short, it's a recitation attendance quiz, but it's not a quiz, it's just a survey. There's no chemistry content in it, it just has like silly questions in it. For you to answer. It'll take you 1 or 2 minutes to complete, but once you submit it, you get your 10 points. So you get that password once you go to recitation, all right? So do not share the password with your classmates. That does fall under academic misconduct. So you just get the password when you show up to those graded recitations. So you'll notice that there are 10 graded recitations. So like the Monday classes, right? There's 12 different graded recitations. Some of them are ungraded. Those ungraded days, your TA will still be in the room. You'll still do an activity with them, but there's just no points associated with that. All right, there's no quiz. All right, so if you don't show up, no one's gonna know. But again, it's you have an expert in the room during those ungraded days. Why not use them if you're there? So 12 graded recitations. In order to maintain a 100% in recitation, you need to attend 10 of them. 10 of them. So in the grade book, I have a rule, drop the lowest 2 grades, which means that everyone gets 2 excused absences from recitation. You only have to attend 10 of the 12, right? Everyone gets 2 drops. So you can have 2 absences, you just need to go to 10. Okay, don't feel like that's a huge ask. All right, and that's to maintain that 100% in recitation, which is 8% of your letter grade. That's like a whole letter grade, all right? So go to those 10, right? So there we go. When you're at recitation, once you finish the 1-minute attendance survey, the rest of the time you work on an activity with your teaching assistant, however they decide to do it. So I provide a packet with practice problems, and your TA may just pick and choose questions for you guys to do together, depending on where we are in lecture that week. So there we go. There are no remote, hybrid, or makeup alternatives to recitation unless you have a flex plan. And then you just have to contact me about those SLDS arrangements. I'll show you the recitation module again, because everything is organized in our course modules. So down here under lecture, there's recitation. So this is the page for recitation you'll go to every week. Here's a copy of the blank packet, all right? So periodic table, constants. This is actually the exact copy of what we give students at the midterm, right? I do this purposely so you know what's coming, right? So here's supplemental information and then just practice problems. So this is a blank copy. What's nice is when you do the attendance survey and you submit it, you actually get a copy of part of the key. So, you know, if you and your TA only do half of the problems in the packet, you still have the full key to the whole packet, right? So that's, you can use this as an additional resource for your studies. Do make sure you're using doing the correct recitation quiz based upon where we are in the week. If you try to put in your password in the wrong week, it won't work, right? And so obviously the password does change from week to week. So look at the schedule, make sure you're taking the right quiz there. I will update the recitation key occasionally on this page, but if you look at your most recent recitation quiz, you'll get the key there as well, all right? So this is the packet and the page for midterm 1 preparation. So this is recitations 1 through 3. Once we get to recitations 4 through 6, it'll be a different page with a different packet for midterm 2, right? So that's what to expect for recitation. Once we get through 1 or 2 days, you'll see the pattern. All right, so that's recitation. Go to 10 of them. All right, calculator policy. So these are the approved calculators for Gen Chem exams. All right, so any one of these ones. Common calculator that students show me is the TI Nspire. This is not an approved calculator for our exams, so you cannot use this on exams. The reason is because of the keyboard. All right, so I know that this calculator was like okay for the ACT or the SATs or something, but it is not approved for Gen Chem. So do make sure that you have one of these calculators for our chemistry exams. But that does mean like on homework and lab and recitation, like we're not checking calculators there. So you can use whatever you want, but I really emphasize and suggest using the same calculator you'll use on exams just so you can get used to that specific device. So I show this now so you know how to prepare for the exam, all right? Because I will take your calculator. If it's not approved, I will take it. All right. I will point out that the program we use for administering exams does have a stock calculator on it, but it's not very good. It takes up your whole screen and it's annoying to use. So that's an option, like kind of like a last resort option, but I wouldn't rely on it. I would get you a calculator that you're used to using for the duration of your Gen Chem career here. All right, so that is calculator. All right. So that's exams. Now I'll talk about online homework. The majority of you already registered for it, so great. The instructions for it are in your start of term tasks, but I'll show how to register for online homework and the policies I have. So in short, you already paid for online homework. It was in the course fees. It's called Carmen Books. I'll show you the instructions to register for it. You don't have to take out your credit card for online homework. All right, so my rules for online homework is I have one assignment per chapter, but it is a long assignment, 2 to 3 hours. That's what mastering estimates to me. But for some students, it takes longer, and this is just because they really want to check their work before submitting questions, and that's perfectly fine. So I have one long assignment per chapter that's always due the following Monday after we finish that chapter in class. So let's pretend we finish chapter 1 today. We're not going to, but let's say I finish chapter 1 today. So when is online homework due? The Monday, yeah, so before we meet next Tuesday, it'll be due on Monday at midnight. Right, and that's a 2-3 hour long assignment. Just because the due date is Monday doesn't mean you have to do the homework assignment on Monday. You can start it now, right? We're gonna go through, a quarter of the slides today. You can do a quarter of the assignment right now. You don't have to wait until Monday when it's due to do the whole thing. And I really encourage you to do that. So you're not scrambling the day it's due. So this is a learning opportunity for all of you for time management, right? So I don't care when you do online homework. I just make the expectation and the policies clear when those due dates are. So yeah, suggest doing questions as we move through the chapter. So these are long assignments, anywhere from like 30 to 40 questions. There's no penalty at just looking at the questions. You also don't need to do them in order. You don't need to do them in order. You can just look at them, look at the questions you can answer right now, do them in any order. There's no penalty at looking at any hints that are embedded in questions, but there are penalties for getting them incorrect. So I do not suggest brute forcing your way through online homework, because if you brute force your way through homework, 1, you'll get a bad grade. 2, you're not learning anything, and you're gonna have to relearn everything before the exam. So you're just wasting time. So why not just learn the material first, the first time when you're doing homework? So that's my strategy for you to save time. Take a long time on homework, learn the material the first time so you don't have to relearn it for your exam. So that's my tip to you. Fully understand before answering that question, because 1, you'll get a good grade on that assignment, and 2, you'll reinforce those concepts and not have to relearn them for your examinations. And then, so Monday at midnight due dates, right? But I do have a late policy in place. So let's say you completely forget that the online homework was due on Monday, you get to lecture today, and your neighbor's like, oh, like, did you do the homework? And you're like, oh no, I didn't do any of it. Have no fear. If you complete all of the online homework assignment, let's say a day late, you'll only get a 10% penalty on those individual questions that you answered late, all right? So let's say you did all of the homework assignment before the due date except the last question. Let's say it was a real toughie and you wanted to see me during office hours to get help. You only get a penalty on that one question you answered late. So this is another reason for you to do homework as we go through the chapter and not wait till the last minute. Because 10% on one question, it's not gonna be a big deal, right? So you can wait to get help. And so my tip is never request or give up on a question. Like, leave that last question blank. I know you wanna complete it, right? But you want those points as well. So it's better to just leave it and answer it late than to just get 0 points and give up on the question and request the answer. Get that help from me so you can get at least some points. So when you request an answer, it's an automatic 0 for that question. So better to answer late. So to access online homework, you can do it one of two ways: either access Pearson through our course menu pages, or you can go straight to the Mastering Chemistry website and log in that way as well. Through Mastering Chemistry, you also get the e-textbook, all right? And again, you already paid for it. Your grade, as long as you go through the steps of registering and all of that, your grade in the Mastering Gradebook syncs with our Carmen page and it updates live. So that means if you do a homework question right now, right, your grade will transfer, that partial grade will transfer to the grade book. So don't despair if you see a really low percentage, because if you only do one question, then that's a small percentage, right? But that grade will continually increase until the due date. So don't despair. Remember, the grades are live, and it'll increase until that due date as you do questions. All right, that's homework. Okay, so here's what homework looks like. Again, you access it here in that link or go straight to the website. So this is what a question looks like. I want to show you here some questions have hints. Use them. There's no penalty at looking at the hints, but there are penalties if you just go through each of these and select them and submit them and get it wrong. You're penalized for that, but you're not penalized for hints. You're also not penalized for using any of the resources. This is homework. It's not a closed book thing. You can use any resources you want. So there are links here in the corner for taking you to the appropriate spot in the textbook, constants, the periodic table, all of that's at your disposal. So use it to get the best grade on homework as possible. All right, so there's online homework. And again, the textbook is integrated with our online homework. Since you did the course fees and all of that, and you have the textbook, you can actually download the textbook and read it on your device of choice via the Pearson Plus app. So if you download that app and log in, you can get access to that textbook and even get offline access to it if you want to read it when you're not connected to the internet. So our textbook has tons of resources in addition to what I post. Each section, as you read through it, actually has multiple choice questions for you to kind of interact with the book to assess your learning as you're going through it. So you're not just reading, you're reading and doing as you're doing it. There's also section summaries for each of the chapters in the textbook. At a minimum, especially if chemistry is not your strong suit, reading those section summaries before coming to class is just a great way to preview the information before I yell at you for 80 minutes about those topics, right? It's like watching a movie trailer before going to the movie. So those section summaries are a great way to just prime yourself before coming to class. So section summaries, also key equations for those sections, and also a lot of practice problems for you to do as well. Though these don't have step-by-step solutions like I give, there are just more resources here for you, all right? You bought the textbook, use it as a resource. I really suggest, as in your time here, try as many study strategies as possible to figure out what works the best for you. Maybe for you, reading the textbook is the best way for you to prepare. Or maybe you don't like reading the textbook, that's fine. You like to do practice problems to assess your learning, that's great as well. I want you to try as many things as possible to figure out what sticks, because the sooner you figure it out, the better your performance on examinations will be, right? Okay, because if you come to me for help, and you're like, I didn't do so hot on midterm one, what did I do wrong? The first thing I'm gonna ask you is, what did you do to study? And if you're like, I did a practice exam, I'm gonna be a little disappointed and basically steer you towards all of the resources we give all students. For you guys, we post 5 practice exams for every single midterm, and I'll talk about that in a little bit. All right, so use your resources, try out and figure out what works for you. All right, class logistics, you're kind of working through it right now. I post lecture slides beforehand, all right, well beforehand, and we just go through the slides together. I download the exact same slides that you guys have in front of you. I fill in some of the blanks, you fill in the blanks. I do, worked out solutions or the problems in there, and I hope you also write the work as well for those practice problems. Because my philosophy is, if I ask you to write out all of your work, I will also write out all of my work for those practice problems. So basically, I go through the same slides you do, all right, just on the big screen here. And so I already showed you our Carmen page of how I organize things, our lecture slides. Note here that I post lecture slides 2 different ways. The first way is 1 slide per page, and then another is 2 slides per page. If you like to print your lecture slides, 2 slides per page is pretty useful to save paper. I also like to use 2 slides per page, that's just me. And then our other supplemental information here. And here you see that this is where your lecture recordings will populate as well on each of these chapter pages. So this one is chapter 5 that I took a screenshot of. So that's how I organize our Carmen page, so do know how to navigate and find where those resources are, all right? Okay, because if you come to me after class and you're like, where will the lecture recording go? I'll be like, you go to the page, yeah, just click around on our Carmen course, all right? It'll be there somewhere, I promise. All right, so that's our class. So do be on the lookout for updates to the modules. I plan to post chapter 2 material tomorrow. But we're not gonna get to chapter 2 until next week. So do be aware of that, especially if you have to print stuff, right? Okay, midterms. I know you're all anxious about this. There's 3 of them. Again, make sure you have the dates and the times written there. Oh, this is wrong. This one's not right. That's not right. That's for my other class, I'm sorry. So I think the earlier one was correct. So don't look at this. So look at your syllabus for those dates, because remember, I'm teaching 2 12-10 classes, so I reused slides here. Sorry about that. But how the exams are administered are the same. So all 12-10 students take the same exact exams, the same exact finals. All of us instructors, we get together and we build the exam and we administer them to all of you. So we call common exams. So since there are 3,000 of you, we are limited by, how fast we can grade, how fast we can get grades back to you. So our chemistry exams are administered via Carmen quizzes, right? So one of the big questions I get every year is, do I have to show my work? Well, one, I hope that you write your work down on exams, but we are limited by Carmen quizzes. So multiple choice, pull down menu, numerical response. We give you scratch paper to work out stuff on your own, but that is in no way graded. So everything is via a Carmen quiz. That's our limitation, all right? So there's a learning curve a bit to learning how to take these multiple choice exams. It can be tricky. So we'll work on that throughout the semester. So those are our exams. The department posts 3 practice exams that are in a similar style of the actual exam. So they're Carmen quizzes. So you can see exactly via the practice exam what our actual exams will look like in a Carmen quiz format. I also post 2 additional practice exams for my students, but they're just paper versions. So it's just a paper multiple choice exam, but just more resources for you. So you have a total of 5 practice exams for every midterm, all right? Rarely do students do all 5, okay? But I encourage you to do all of them if if you're worried about your success or your grade. Do all of the practice exams and questions that I provide. Because I like to provide my own practice exams because I have very detailed worked out keys for all of them. So that's why I post additional ones. Yes, so I also hold a 2-hour review session for every exam, and I open it to all 1210 students. It's a madhouse. Yeah, 3,000 of you. So I do it in person, but I also have a Zoom option for it too because there's just so many students. So be on the lookout for that information as well for our exams. And then finally, the final exam is cumulative, so all chapters 1 through 12. We'll worry about that later. Okay, let's keep going. Okay, resources for you. I have office hours on Tuesdays and Thursdays. So I actually have office hours in a McPherson room up here directly after class. So you can just follow me. All right. On Thursdays, I have office hours before my first class. So my first class is at 11:10 in this room. So it's at 9:30 in another McPherson room up here. All right. So you can come to either. These office hours are very informal. We all just hang out in a classroom. We do practice problems together. It's not formal at all. All right, you don't have to make an appointment. You just come in and we hang out. You don't have to stay the whole time either. All right, you can just come for a little bit, whatever your schedule allows you to do. To encourage students to come to my office hours, if you come to my office hours, I will give you a small gift to help you in your chemistry studies. It is not extra credit, because there's no extra credit in this class, okay? But it will help you in your studies, okay? So come to office hours. Also, so I'm not the only point of contact. You can also contact your TAs for, lab-specific or recitation-specific questions or something, all right? Also, there's the Learning Resource Center. It's a drop-in tutor room in the back of Celeste Labs. It's on the first floor. They have 2 or 3 TAs in that room from like 8 a.m. to 5 p.m. every day. They also have some Zoom hours in the evening and some Zoom hours on the weekends. So this is drop-in tutoring. So for example, if you just want to do online homework and you want to do it in a space and have like an expert just, at arm's reach at all times, that's a great place to do it. All right. So again, I want you to try out as many study strategies as possible during these first few weeks. Go visit the Learning Resource Center to see if there's TAs that you jive with and you just like the way they explain things. Those resources are for all students. All right. Textbook is a resource and all the resources I post online. All right, keep going. All right, so tasks for you, this is kind of important. Register for online homework. Get 100% in that academic misconduct quiz. If you don't, you might be dropped from the course. Take the safety and lab policies quiz and take my syllabus gatekeeper quiz to unlock Carmen, the rest of the Carmen modules and explore our Carmen page. Right? So this is an important list for you to do. Also, this is all in the start of term tasks as well. Okay, this is kind of a leftover from COVID. This is an in-person class. Everything is in person. We do have absence policies in place. Notice that in the grading scheme, I do not have a lecture grade. I don't take lecture attendance. You don't have to tell me if you miss class, but it's up to you in the end to get caught up. I'm not going to tutor you one-on-one and tell you what you missed. You can use the resources that I provide to all students, such as the lecture recordings. You can talk to your classmates, but I'm not going to tutor you one-on-one if you miss class. I have 600 students. I can't do that. So do be cognizant of the resources I provide to all students. So look around right now, all right, at all your classmates. This is the most number of students you will ever see in this room, right? I promise you. Once we get 2-3 months in, we'll see people drop off, not because they drop, but I don't know, maybe they rely on the lecture videos, I don't know. But so do recognize I do record these lectures, but technical issues do happen. I've actually never had a year where every single lecture video was 100%. I always have one video that gets screwed up somehow, all right? I don't know which one it's gonna be, and I can't travel back in time to like fix it, all right? So do be aware technical issues do happen. And if you miss a class and the video gets screwed up, there's really nothing I can do. I'll point you to Dr. Foos's supplemental videos, but that's all I can do, all right? So yeah, but also if you don't come to class, you miss out on the demos, okay? You just hear my voice and you just hear the loud boom and that's it, but you don't see the cool demos, all right? So come to class. All right, how to reach me. Again, I have office hours, don't schedule. You don't need to schedule anything if you're just dropping into office hours, but if these hours don't work for you, or if you want to talk about something more personal, just email me and we'll arrange something outside of those times. And you can come to my office here, but if you just come to open office hours, you'll never really need to come to my office. But also, you can email me anytime. Like all millennials, I'm attached to my phone all the time. So if your email has all the information I need to answer it from my couch, I will answer it, right? So make sure, one, you tell me what class of mine you're in. Don't just say 1210, because I teach 2 1210 sections. So I have two different folders. I have 2 different classes I have to navigate on mastering and all of that. So tell me what the start time of your lecture is, especially if I need to like look at a grade or something, if I have to like look you up, tell me the start time of your class. So say 12:45, and then that's all I need. And email me directly from your OSU email, only at that email address. Don't do the Buckeye mail email for me, because it's actually a separate inbox. So don't email this, okay? Outlook might try to like auto correct it to that, but don't send it to that one because it's a different inbox. Only send it to this email address right there, all right, if you want a fast response, all right? Don't use Carmen messaging. Again, if you want a fast response, only email this directly because it goes straight to my phone. Yeah, so say what class of mine you're in, the time, that'll be helpful. And your TAs can also answer questions, and then the LRC is a resource. All right, okay, lab schedule. So notice that I've talked very little about lab, and again, it's because I am not involved with lab too much. And actually, a lot of the questions I got at the beginning of the year have all been about lab, unfortunately. But I'm not very much involved with lab. So many of the emails that I sent out always started with email the lab supervisor. But if I knew the answer, I would try to answer it for you. So I'll just keep this sweet and short. Many of the questions on your mind should have been answered by your lab TA who emailed you earlier this week about information about starting lab. We do start labs this week, and I know the schedule looks very daunting, but again, like the recitation schedule, if you meet for lab on Fridays, all you need to do is look at the Friday column. You don't need to look at anything else. So if you're in a Friday lab, you're gonna do WRM this week. And what you need to have prepared for that lab is essentially just going into lab with the proper attire and your lab coat. That's basically all you need to do. You don't need to prepare a notebook or anything. That's all embedded. You'll do that in the lab space. So what you need to do for this first lab, get that lab coat and wear appropriate clothing. So rule of thumb is that no skin below the belt should be showing. So like what I'm wearing right now is fine. because everything else is going to be covered by a lab coat. So closed-toed shoes, long pants. I know like it's hot right now, people are wearing shorts, but bring some sweatpants or something for lab. Your lab TA will send you away if you don't have the right attire on. So you do need to buy a lab coat, but goggles will be provided to you by your TA when you walk in, when you're in the lab space. Okay, that's the lab schedule. So these are the tasks for lab. Purchase your LabRite access. That's in the lab module. The lab manual is the second link in our lab module. You'll need to know your lab section course ID. Again, it's different from the lecture course ID. So you need to look at like your Buckeye link schedule. That's two different numbers. Don't pick the lecture one, pick the lab one. Purchasing LabRite will give you digital access to the lab manual, but once you purchase it, we will also give you a physical copy of the lab manual as well. Make sure you purchase that lab coat from Celeste 180. Buy your first lab and make sure you wear appropriate attire and then do those last quizzes for lab, and it unlocks the lab module. So those are the tasks for lab. Again, these are in the start of term tasks. All right, so we're done. I will show you step-by-steps to get access to mastering chemistry. Oh, I should actually point out. So LabRite, you do have to take out your credit card. This, you do have to actually pay for it. But mastering chemistry, do you have to pay for online homework? No, you already paid for it. All right, so yes, LabRite, you do have to purchase it, but mastering chemistry, you do not, as long as you follow these instructions. Go to the start of term tasks. You want to click on online homework, e-textbook, and you want to bring up a PDF that looks like this. There is a 6-word access code in there somewhere. All right, so keep that nearby. Then you want to go to our Carmen course. I suggest doing this in a web browser or on a desk or like a laptop. Sometimes it's weird with your iPad. You want to click on Access Pearson and then click on Open Pearson. And you want to click on some yellow buttons, and then you want to click I accept to some stuff, and then you want to sign in. If you already have a Pearson account, go ahead and use that one. It doesn't have to be your OSU email, but if you don't have one, you can create one with whatever email address you want. It links to Carmen automatically. So register or sign in, and then the most important thing here is you'll get to a page that looks like this, and you want to select access code. And then you put in your access code that you saved on the other page. You do not need to pay. Don't pay. Don't do free trial, okay? You already have it via the access code, right? And then that gives you full access to online homework. It links you to our class, and it gives you full access to the textbook. Okay, any questions? Okay, we're gonna jump right into chapter 1 unless there's any questions from the balcony. No? No questions? I know I just threw a bunch of information at you. Yes? No, so where you buy the lab manual, so go to the lab module, and then you click on, it's the second link, and it says like lab manual, and there's instructions on that assignment that say how to purchase it, right? Okay, great. So then we are gonna jump right into chapter 1. Okay, chemistry. All right, so these are our chapter 1 slides. So go to the chapter 1 page to get these slides. You'll notice, my lecture slides, I like to be predictable and have them be similar. So at the beginning of every chapter, if there's something that I think you need to memorize, I always write it at the beginning. The reason is because I don't want you to wait until we get to that part of the slides for you to start memorizing something. Because like in high school, if you needed to memorize, like let's say the metric prefixes in high school, oftentimes that teacher allowed you all week to do that, right? But here it's like I tell you to memorize something, I expect it to be memorized by the following lecture. Right, so I always write what I think needs to be memorized at the very beginning so you can anticipate that and apply it right away when we get to that section. Because I'm not going to help you memorize things. We're going to go straight into applying those concepts in this class. So do memorize those prefixes. All right. So here are the sections in chapter 1 that we will be covering. So let's just jump right into this. Okay. Studying chemistry. So with this slide, you see chemistry is at the middle of this like spider web of all of these different topics, these different majors. Here in our textbook, they talk about chemistry often being referred to as the central science. And you see, because it's like central to the spider web of topics. Does anyone know what our book is called? Chemistry, the Central Science. How creative, right? Yeah, in order to really fully understand like biology, you need to understand the chemistry that's going on within biological systems. In order to, a lot of physics and chemistry overlap, right? The new movie Oppenheimer. I didn't watch it, I watched Barbie instead. A lot of physicians or physicists within the Manhattan Project, but they were working with radioactivity, chemicals, chemistry and physics definitely overlap. So that's why they call it the central science, right? And it's because chemistry is so broad. So to define chemistry right here, it says chemistry studies matter, so things, and its properties and behaviors. So that's what we're going to be doing today. So it's a simple definition. We're going to be studying matter, but we're going to go into detail about it. We can observe properties and behaviors of matter, but we're going to relate it to that matter's composition, so what it's made out of. We're going to relate it to its structure, how those atoms are arranged with one another, all right? So that's the big detail in chemistry. We're looking at things that we can't see about matter, like what it's made out of, how those atoms are arranged, and applying that to the things we can see, its behaviors and its properties. And that's one thing I love about chemistry. We're relating to things we can see to things we can't see, right? So it's something I constantly refer to as the secret to chemistry, that composition and structure dictate the properties and behaviors that we see. And I'll constantly be referring to that, the secret to chemistry. Composition and structure dictate chemical properties, all right? Okay, so we need to make sure if we're talking about and studying matter that we're all talking the same language. So I think this is why chemistry is really difficult, because we are talking about matter in using different forms of language, right? So we talk about matter in terms of things that we can see, so observations. So for example, I have a picture here of a beaker of ethanol, right? To you, what does that look like? A beaker of clear water. Yeah, colorless water. Doesn't it just look like water? So those observations, ethanol being colorless, we can see through it. That's our macroscopic domain. These are observations we can see with our eyeballs. We can sense it. Ethanol has a certain smell to it. That's something we can sense. Right? So those are the properties that we can observe, but we're relating these things, like the observations of samples that we see in lab, to a microscopic domain, a domain that we actually can't see. We actually have to imagine what ethanol molecules look like on this particle level. And that's what's difficult for students. That, these pictures that I have of ethanol molecules, this is just me trying to represent what ethanol actually looks like on a particle level. Can you see atoms? No, you can't. It's way too small. All right, so we have to imagine it with this microscopic domain. So what we think particles look like. So that's our second language that we're using. Trying to imagine what these particles look like. And then finally, to make it even harder, is we have this new language, symbols, to represent what we're actually talking about. And this allows scientists to communicate with one another. Okay, here's the composition of ethanol. There's 2 carbons, 5 hydrogens connected to an oxygen and another hydrogen. So we're using these chemical symbols, formulas, reactions to communicate what changes, what substances we're talking about. So 3 different languages all intertwined together. And we're going to be constantly jumping from domain to domain to domain in both 1210 and 1220 and basically all of your science career, right? And so here within the symbolic domain, I actually have 2 different kinds. The molecular formula that just tells us the elements or how the atoms are, what atoms are present, so composition, while the structural formula tells us a little bit more information. It also tells us how the atoms are actually bonded to one another. So it gives us a tiny bit more information. But both of these are communicating similar things, what substance we're working with and studying. So in this case, ethanol. All right. Okay, so this isn't in your slides. I just think this is a cool little thing, the map of chemistry. So we are dealing very much with like the green side of this map. I have this on our resources page for chapter 1 if you like this little figure. We're worried more about like the rules of chemistry, rules of bonding, types of reactions. So that's what you'll study in Chem 1210 and 1220. But once you have these fundamentals under your belt, you'll be able to apply a lot of these concepts to actual applicable topics that we use in everyday life. So like biology, catalysis, fuels, computational chemistry, things like that. So we need to learn the rules first before we can do really cool things. So me personally, I am kind of more in this part of the application map of chemistry. So the inorganic portion of this map. Me personally, I don't like living things. I don't like biology. But you can try to convince me otherwise. If you see a cool application of chemistry and bio, I want to hear it. But I don't know, when I tell stories of bio, they just don't hit like very well because I'm not very good at explaining bio stuff. Instead, I work with inorganic things, so dead things, so metals. So I like metals. Also metals, when we have metal compounds, they're cool colors, but like organic and like biological things are mostly white or colorless, so it's boring. I like colors. So yeah, not a fan of bio. So you'll learn that from me if you follow me from 1210 to 1220. But you can try to convince me otherwise. I'm an inorganic chemist, so I'm right here on this map. All right. Okay, so that's the context. So just looking at a simple picture like this of water boiling, like you look at that picture and you can tell, oh, this is like water, we're heating it up and it's boiling. You can kind of tell from this picture. So there's a lot of subtleties in this picture where lots of domains are acting at once. With our eyeballs, we can tell, okay, yeah, this is like liquid water, it's bubbling, it's boiling. We can use chemical formulas and equations to represent what's happening. We have liquid water turning into gaseous water, right? What domain is that? This one. Which domain? Symbolic, yeah. All of these mean the same thing, right? We see water boiling, we can write water boiling, liquid to gas, and then we can also draw on the particle level what this looks like. Water as a liquid sample, all those particles are packed together, versus in a gaseous sample, they're far apart. And that's something we need to imagine with our minds. And you kind of have to have blind faith in me that gases tend to have less particle density than the liquid or the solid phase. All right, this is just something as simple as water boiling. And one last symbolic chemical change here is our Bunsen burner running as well. So this is a combustion reaction. So a different reaction is occurring versus our phase change up here, where we take methane, it's reacting with oxygen to make CO2 and water. But that's how we communicate to scientists that this chemical reaction is happening through our symbolic domain. So a lot of subtleties here with thinking about the particle level, relating it to our observations, and relating it to chemical formulas that we can write. All of them mean the same thing. Okay. All right, so those are our domains. That's the language we're going to be speaking for the next, I guess, year, since many of you will take 1220 as well. Okay. All right, so let's make sure that we can classify the matter that we're studying. So I mentioned chemistry is the study of matter. The definition of matter is something that has volume and occupies volume and has mass. So let's think about this. Tell me, is this matter or not? The air we breathe, is that matter? Yes. What about an apple that I ate for breakfast? Does that matter? Yes. Is happiness a matter? Does that matter? No, happiness does not matter. My tip for determining if something is matter or not is if you can put it in a jar, then it's matter. So can you put an apple in a jar? Yes. Can you put happiness in a jar? No. What about the chemicals released to create happiness? So like the chemical serotonin. Is that matter? Yes, it is, because I told you it's a chemical. It's a chemical. Serotonin or dopamine, all right? Those two chemicals produce the feeling of happiness, although happiness is not matter. So we will be studying things like chemicals, substances that we can actually weigh out and make observations about. So in order to study matter, we need to be able to classify matter. And so our two broad categories are pure substances and mixtures. 3 of these we will study the most. All right, so within pure substances, we have elements and compounds. We'll be studying this. And then within mixtures, we have 2 different kinds, homogeneous and heterogeneous. For the most part, we're not going to worry about heterogeneous mixtures, but we will talk about homogeneous mixtures. And I have here a synonym for homogeneous mixture, and that's solution. Homogeneous mixture and solution mean the same thing. They mean the exact same thing. But I had the abbreviation for solution. I oftentimes write it like that, SOLN. So you'll see me write it like that, right? So those are our types of matters. Let's talk about the differences between pure substances and mixtures. So pure substances often will always have uniform properties within them, all right? So my tip for determining whether something's a pure substance or not is if you can write a single formula or use a single symbol from the periodic table to represent that, right? So a pure sample of water. Water has what formula? H2O, yes. And so since I can write water with a single formula, that is a pure substance, right? A pure sample of oxygen, O2, that's an element on the periodic table, also a pure substance, right? Table salt, does anyone know the formula for table salt? NaCl. Is NaCl, salt, a pure substance? Yes, because it's a single chemical formula. NaCl, they're bonded together, all right? So the difference here, like H2O, NaCl, those are like multiple elements, but they're bonded together. O2, on the other hand, is just an element, but it's still a pure substance because it's just one thing off the periodic table. That's different from mixtures, okay? Mixtures have more than one pure substance present that aren't chemically combined. So my example here is salt water. What is salt water made out of? Don't think about it too hard. Salt and water. Yes, so salt water. Salt, water. So if there's salt and water present, can we represent salt water with a single chemical formula? No. Salt is present, and salt is NaCl. Water is present. Water is H2O. Both of those things are present in that sample, but those 2 separate pure substances, they're not chemically combined. We've just mixed them together, right? And so another detail with mixtures is that we can actually further define mixtures as, since those 2 components are not chemically combined, we can separate them. We can separate them with physical means. So if I gave you the task of separating salt water, do you think you could do it? Yeah, how would you do it? Someone. And boiling it. So what would boiling the sample of salt water do? Yeah, the water would leave and the salt would stay. So that allowed us, just boiling it away, allows us to separate those pure substances back into their pure forms. The water is now over here, the salt is still in the beaker. So that's the big difference between mixtures and pure substances. All right, so let's go into more detail here. Wait, we're over at when? 2:05? Okay, so I do want to leave enough time to blow some crap up. Yeah, so that's why we come to lecture. So we'll do a couple more slides and then blow some stuff up. All right, so let's talk about pure substances first. Again, what's my trick with a pure substance? If there's a formula, if there's one symbol, it's a pure substance. So of pure substances, there's two types. There are elements. So if it's on the periodic table and it's just like one of those things, then it's a pure substance. But then we also have compounds. So compounds, on the other hand, they're built with different elements on the periodic table, chemically combined. All right, something like water, H2O, or NaCl. Though, since we just represent it with one chemical formula, is still a pure substance as well. So elements, we have our periodic table here. Remember, you will always get the periodic table at exams. They just won't have the chemical names on them. All right, so my strategy here for you is do make sure you're able to know the names and the symbols for the first 56 elements. All right, so if I ask you, what is the atomic number of barium? Is that something you need to memorize? No, you should look to the periodic table. Barium is what symbol you think? Ba, yes, so that is something you need to know. You need to know barium is Ba, and it's element number 56. Versus, some of you might have been thinking, oh, I thought it was B, but just a B is element 5. That is element boron, all right? So we need to know those differences, that B is boron, Ba is barium. So that's the extent of memorizing the periodic table you need to do. Who here had a high school teacher make them memorize the periodic table? Raise your hand. Okay, your teacher was lazy. Because as a chemist, you always have access to the periodic table. That's literally like not good use of your brain space to memorize the periodic table because you always have access to it, right? So the small task I'm putting on you is do recognize those chemical symbols. There are some weird ones, all right? Barium, a little bit obvious. You could kind of think your way through that, but the weird ones are like iron, which is what? Fe, copper, Cu, silver, gold, mercury. So those are like the weird ones. So do take special care of those examples. All right. Okay. Compounds, on the other hand, two substances chemically combined. So here's an example of like NaCl, and then here's H2O. Right, so all water molecules have the same composition, 2 hydrogens attached to 1 oxygen. So this water sample is just that H2O molecule copy and pasted a billion times, right? So that's why we call it a pure substance, because water, regardless of where you find it, each water molecule is exactly the same. H, 2 H's bonded to 1 O. Right? And so compounds, again, a formula, one single formula representing that substance. All right, so I'm gonna skip this slide. I wanna end on these last slides and then blow up some stuff. Actually, no, we have time to do this slide. Okay, atom versus molecule. So we talked about compounds, where we're combining atoms to different elements to form a larger array of a molecule or a compound. So just to clarify some terminology, an atom is like a single element on the periodic table, like a single particle, right? So for example, neon is an atom because it's just like one thing on the periodic table. But once you start combining things and bonding things together, like O2, O2 is not an atom, it's actually a molecule because we've bonded 2 oxygen atoms to make a molecule, all right? But where neon and oxygen are similar are that both of them are elements, All right, both of them are elements because neon's on the periodic table, oxygen's on the periodic table. It's just how they exist in our world are a little bit different. That neon is an atom, oxygen is a diatomic molecule. And so what the point of this slide is, I just want to be really clear of my terminology. All compounds are molecules, because compounds, we need to combine different elements together and bind them together or bond them together, but not all molecules are compounds, because some molecules are elements, such as diatomic oxygen, right? In order to have a compound, we need to have different elements present, right? But as long as we have two atoms bonded to one another, if it's the same element, it's still an element, but now it's a molecule. So let's see if we can't go through these examples here. CH4, is that a molecule or an atom? Molecule, yeah, because we have junk bonded to each other. But is CH4 an element or a compound? A compound, yes, because more than one element is present. All right, we did neon and oxygen. Neon's an atom, but oxygen is a molecule, but both of them are elements because they're on the periodic table. What about SO2? What is that? Molecule and a compound, and then S6. Molecule, but an element. Yeah, so similar to like O2, all right? So that's just clarifying terminology there, all right? All compounds are molecules, but not all molecules are compounds. Okay, so we have 5 minutes, so I'll talk about the secret to chemistry, because I told you we'll be talking about this a lot, and this is why I love chemistry, because there's a lot of subtleties to explain why we see things, with our macroscopic observations. So I told you the secret to chemistry is that composition and structure define or dictate what properties we see. Composition meaning the atoms that make up that substance, okay? Structure meaning how we build that substance. So if you think about it like Legos, right? You can have the same 5 Lego pieces, but you might build something different than like your friend builds something, how you put those Lego pieces together. And depending how you put them together dictates what properties we see. And that's the beauty of chemistry that I love to see. So here's an example. All 3 of these substances have the same chemical formula, C3H8O. So all of them share the same what? Composition or structure? Composition. Both of them are made of the same Lego pieces, but they're built differently. Here, the red Lego piece is on the end. Here, it's in the middle, and here it's like in between 2 black pieces. All right, so composition's the same, but the structure is different. And what we observe are 3 wildly different boiling point temperatures. Just based upon, we see these differences because of how those atoms are actually bonded together. And I think that's a really cool thing. They have the same composition, made of the same stuff, but because of how those bonds, the structures and atoms are bonded to one another, yield wildly different properties. You think that's cool? Yeah, that's cool. No, that's boring. Different boiling points. Let's look at a better example of composition versus structure yielding different properties. Okay, here's an example, right? I have 2 different compounds. Platinum, 2 chlorines. All right, and then both of these substances have these NH3s attached to them. So look at these 2 compounds, cisplatin and transplatin. Composition, are they the same or different? Same, yes, both of them have platinums, chlorines, NH3s. What about their structure? Look very carefully. They are different. Yes, this one, the 2 chlorines are next to one another. They're sisters, that's why it's called cisplatin. And then the other one, the 2 chlorines are across from one another, so that's transplatin, right? So here's an example. Composition the same, structure different. One of these compounds, cisplatin, is the #1 cancer-fighting chemotherapy drug out there on the market, cisplatin, right? So cisplatin, because of how those 2 chlorines are arranged, it's in the perfect geometry to cross-link with an RNA helix, all right, during RNA-DNA replication. So cisplatin targets cells that are fast replicating. What does a fast replicating cell sound like? Cancer, a tumor, all right? So cisplatin is the #1 drug to do that. Transplatin does nothing. does nothing. All right, so here's an example where one of the compounds with this composition kills cancer and the other one does nothing, right? And so I think that's a better example of composition and structure, all right? But thank you for believing me with the boiling point one. All right, so I'm gonna end this class with a bang to kick off and set the tone for this class and convince you all to come to class, because we'll do cool things like this. All right, so here I'll show you the equation that we're doing. All right, the reaction that we're doing, we're reacting H2 and O2 to yield H2O. So we're just making water here, all right? But this is a chemical change. We're actually doing a chemical reaction. All right, so this is very loud. This is very loud because we are at a very large university. We have good resources here so I can do things like this. So this is very loud, so I need everyone to either close their ears like this, and I mean every one of you, okay? Close your ears, or if you wanna like feel it, you can do like Dumbo ears and like cup your ears and like listen to behind you, or if you really wanna feel it, okay? So I need every single person to cover their ears, okay? It's very loud, all right? I'm checking every single person. Okay, I don't want to be the reason you have tinnitus or tinnitus. All right, so this will set off the tone for this course. Oh no. Okay. Ears, everybody. All right, let's have a great year. There we go. Right, come to class and we'll see demos. Oh, and then we'll just go to office hours.